students. In this video, we are studying about Maclaurin series. Let us take one example. Expand e raised to sin x by Maclaurin series up to the term containing x raised to 4. The Maclaurin series up to x raised to 4 is given by y of x is equal to y of 0 plus x y1 of 0. Here y1 of 0 stands for the first order derivative at x is equal to 0. Similarly, for the next term, it is x square by 2 factorial y2 of 0. y2 stands for second order derivative at 0. The next term is x raised to 3 divided by 3 factorial, the third order derivative at 0, plus x raised to 4 by 4 factorial y4, which is the fourth order derivative at 0, and so on. So this is the Maclaurin series expansion about the point x equal to 0. So here we need to find out y of 0, y1 of 0, y2 of 0, y3 of 0, y4 of 0, and substitute in this expansion. So given that, let us take y of x is equal to, or simply y is equal to e raised to sin x. So find this derivative at x equal to 0. So y of 0 is equal to e raised to sin of 0. Sin 0 degree is 0. So we have e raised to 0, which is equal to 1. So y of 0 is equal to 1. So we have this term as 1. Now go for finding y dash of 0. So for that, it is y1 of x is equal to, we see that the derivative of e raised to sin x is e raised to sin x itself. Now it's a composite function. The derivative of sin x is cos x. So here put x equal to 0, we'll get the value y1 of 0 is equal to e raised to sin of 0 into cos of 0. E raised to sin 0, as we have calculated this as 1, and cos of 0 is also equal to 1. So therefore it is 1 into 1 is equal to 1. Now before we go for the next order derivative, we see that this e raised to sin x can be written as y. So this will write it as y cos of x, so that our next differentiations will be easier. We'll go for the second order derivative. y2 of x is equal to, now here there are the two functions. We'll apply the product rule. For the product rule, keep this y as it is. The derivative of cos x is minus sin x. So it is minus sin x plus the derivative of cos x. Keep the cos x as it is. The derivative of y is y1. Now find the same at x equal to 0. y2 at 0. We know that y at 0 is 1. It is 1 into minus sin 0 plus cos of 0, and here the value of y1 at 0 is 1. Now sin of 0 degree is 0. So therefore the first term becomes 0. Cos 0 is 1. It is 1 into 1 will be 1. So y2 of 0 is equal to 1. y1 of 0 is also 1. Y of 0 is also equal to 1. We'll go for the third order derivative. So y2 of x is given by minus y sin x plus y1 cos x. So find the third order derivative y3 of x. We note that for both of this we have to use the product. So let me keep the minus sign outside and differentiate y sin x by using the product rule. Y as it is, the derivative of sine is cos of x plus sin x as it is, the derivative of y is y1. So this is the differentiation of only the first term. Similarly, we need to do it for the second term also by using the product rule. Keep the y1 as it is, derivative of cos is minus sin x and cos x as it is, the derivative of y1 is y2. Simplify this. On the simplification, it is minus y cos x minus of y1 sin x minus y1 sin x plus cos x y2. So that can be written as minus y cos x it is minus 2y1 cos x plus y2. So here it is y1 sin x y2 cos x. Also we can note that this minus y cos x, we can also write this as y1. So this will be minus y1 minus 2y1 sin x plus y2 cos x. So here we have put y cos x is equal to y1. So we have simplified this. Let me go for substituting x is equal to 0. So y3 at 0 is equal to y1. The y1 at 0 is 1. So it is minus 1 minus 2 into y1 which is 1 sine of 0 is 0 plus y2 is also 1 cos of 0. Cos 0 is 1 and here sine 0 is 0. So this term will be 0. It is minus 1 plus 1. So we got y3 of 0 is equal to 0. So we have the third order derivative at 0 is 0. Similarly, go for the fourth order derivative which is y4 of x. Now the derivative of y1 is minus y2. Here we need to go for the product rule. So keep minus 2 as it is. Use the product rule. So y1 as it is. The derivative of sine is cos x plus sin x as it is. The derivative of y1 is y2. So this is for the term y1 sin x. Similarly, differentiate y2 cos x by the product rule. It is y2 as it is. The derivative of cos x is minus sin x plus cos of x as it is into derivative of y2 which is y3. Simplify. We have minus y2 minus 2y1 cos of x minus of 2y2 sin of x minus y2 sin x plus y3 cos of x. So this we have it as minus y2 minus 2y1 cos x minus 2y1 cos x. Here these terms are same, so adding it is 3y2 sin x plus y3 cos of x. So this is the differentiation up to fourth order. Now take x equal to 0. It is y4 of 0 is equal to y2 is minus 1, y1 is 1, cos of 0 minus 3, y2 is also 1, sin of 0 plus y3 is 0 into cos of 0. So here sin 0 is 0, this is 0. Both of these terms are zeros here. So we'll get minus 2 minus 1. So y4 of 0 is equal to minus 3. So since the question is asked only up to x raised to 4, so we'll find the derivatives up to fourth order derivative. Substitute all of this in the Maclaurin series given by this expansion. So we have e raised to sin x is equal to y of 0 is 1 plus x, y1 of 0 is 1 plus x square by 2 factorial, y2 of 0 is also equal to 1, x raised to 3 by 3 factorial, y3 is 0, then x raised to 4 by 4 factorial, the fourth order derivative at 0, we got it is minus 3. On simplifying this, we'll get 1 plus x plus 2 factorial is 2, so it is x square by 2, and here the 4 factorial is 24, minus 3 by 24 is 1 by 8. So it is x raised to 4 by 8. It is the expansion e raised to sin x by using the Maclaurin series. Thanks for watching.